Hi folks, so this is a video about the types of functions. So injective, surjective and bijective. So these are the names of types of functions. So a function can either be injective, it can be surjective, but the thing about it is that a function must be both injective and surjective for it to be bijective. Alright, so these are very confusing and the words are um, yeah, it's kind of easy to mix them all up, but just have a look and we'll try and get to terms with it. So the first one is injective. We'll just go through that. So it says here everything in the input goes to one output, so only one output. So this is 1 to 1. So that's often what it's referred to. So if you look here that everything in the input only goes to one thing in the output. Now you'll spot there that there's an 8 that's extra, so that's okay. That's fine if there's something extra in the output, alright? The thing that you have to be watching for here is, and that's easiest to see, is that if you have two things, so just say that arrow isn't going to 9 there from 5, if 5 is also going to 7, so if two things are going to 7, for example, or it could be the same with any other one, so that two things in the input are going to the same output, then it's not injective, and that's one of the easiest way to see it's not injective. So that function could be something like f of x is equal to x plus, it's probably x plus 4. Now there's numbers in the input, so everything you can add on 4, so there's nothing there for 8, but 8 is still there. So that's injective. Surjective is the opposite then. It's that thing that I was just saying there. You'll see there B goes to F and A also goes to F. So two things go to an output or to the codomain. So it says every element of the range is the image of at least one element of the domain. Okay, so at least one element of the domain. So you can have more than one things go to the same output. So an example there is y equals x squared. So you'll know already that, just say for example 2 was in the input there and minus 2 was also in the input, but then 4 was in the output. Well, then minus 2 would have to go to 4 and 2 would have to go to 4, because if you square either the numbers, you're putting them into this, then you're just squaring them. So minus 2 squared is 4, but 2 squared is also 4. So that's an example of where they go to the same output. So y equals x squared is an example of a surjective function. Bijective, then you'll see that everything just goes to 1, so it must be both injective and surjective. Every element in A goes to exactly one element in B, so you can't have any extra. You can't have another something else here like 10. That's not allowed for bijective, and it's also not allowed for, like what we were just saying, for two elements in here to go to the same element in B. So that's a quick rundown of what they are. It's still probably confusing, but they're the things that you have to watch for with these. There's also a thing called a horizontal line test. So if you're looking at a function on a graph, so something like this would be an injective function. So if I was to draw a horizontal line anywhere along it, it only cuts it at most once. Okay, so that's an example of an injective function. Surjective, then I'll give you the one that I gave up there, y equals x squared. That's an example of surjective because it cuts it at least once. So this is the graph of y equals x squared, so you'll see there if I draw it there, it cuts it twice, so it cuts it at least once, so therefore it's surjective. So the ones that are bijective then are the ones that cut it just the once. So the first one I drew there would be a bijective one anyway, so something that is only once. Right, let's have a look. So there's different types of questions. It's hard to pin down really types of questions you can get here. You can be asked an awful lot of things. This is just an example of some questions, and it gives you a function on the graph. So what's the range of f? So the range of f here, it would be the output. So that's going to be everything on the y-axis. So you see that it starts here at -2, and then there's nothing that down below -2 where the graph is. So it's everything up there. So it's just from -2 up. So -2 infinity. Right, so we have to explain now why it's not injective. Well, you could do the horizontal line test anyway. That's just there. So you can see that it cuts it twice. So that's one reason. You could write that down. Or you could say that you'll see here -2, and they have it on the graph anyway. -2 and 2, they both go to the same output. Okay, so their output is 2. So if I put a -2 into the x there, I have -2 squared, which is 4, and then take away 2 is +2. So it gives me that 2 as the output. But if I also put the 2 in, 2 squared plus 4 is, 2 squared is 4, -2 is 2, it gives me 2 as well. So whatever I put in, it gives me the same output. So two things have the same output. That's the reason. Explain why f is not surjective. Right, so the reason that it's not surjective is because if you look up here, so the codomain here is the reals, so R onto R, but in the range is actually just from -2 up. So the range is what we said here at the start. So -2 up to infinity. So for it to be surjective, the codomain and the range have to be the same thing. So if it kept going down here to infinity, then it'd be okay, but it's not. So it's not surjective. So suggest a domain for f to make the function injective. Okay. Right, well, if we cut away the kind of the left hand side of the graph, so if we just left it from here going up, then it only has one output for every input, so therefore it is injective. So that would be a domain. So that'd be a domain that would leave it to be injective. So the domain then would be x is greater than or equal to 0, because we're only looking at this side. Suggest a codomain to make the function surjective. So a codomain, well, it would have to be everything. It'd be the same thing. So it'd have to be everything above -2. So it's everything above here. So that would have to be the codomain, because then it would include everything. So x is greater than or equal to -2. So something like that. Right, so this question then, this is similar again. It's actually similar to the first example. So quadratic function, so something like that. Is it an injective function? So the problem again is something you've got, it cuts it twice on the horizontal line test. Also, two values are going to go to the same thing. So -3 and 3 will go to the same value on the y-axis. That's why it's not injective. Why is it not? Is g of x a surjective function in the range y is less than or equal to 2? Well, for it to be surjective, every part of the codomain must be used. So here it's not used. So y is less than or equal to 2. It's not being used. So to suggest a restriction on the domain to make g of x an injective function. Well, again, similar answer to up above. Shouldn't really have used this example really, but everything this side. So if you just go everything this side, so for x is greater than or equal to 0, that's a codomain that's a domain where so you're basically cutting off this side of the graph. So now it's 1-to-1, so it is injective.